Hi, thank you for having me. Yeah, today I want to talk about how we use Angular in our company, how we use Angular in a large enterprise project, what we've learned, and I hope I can also show you how we improved our work and how maybe you can learn from our mistakes or our learnings. So, as you know, I'm from Germany, and I don't speak Russian, but I've learned to do a little introduction in Russian, so I now will try it and see how far I come. So, меня зовут Leonard, я работаю senior front-end developerом в компании Ion. Я живу в Эссене, Германии. Там тоже организую Angular Meetup. So yeah, great. I want to give a little bit about, talk a little bit about what I'm going to present. And at first, I want to show you our use case, so what we work on, to give you a little bit more of context, so that you understand where our problems or our solutions come from. I want to talk about code examples, I want to talk about what a sustainable application is and what we've learned to make an application a long-running application and a maintainable application. I want to talk about code examples because I think we've all heard a lot talks about theory, about Ivy, about some renderer, some Bazel or something, but sometimes it's also cool to see like how that actually looks like when you apply it in real-world examples. One of the examples will be immutability and how we use it in our project, how it helped us, how we typed our IDs and what benefits this had, how we used assert unreachable, and as a little bonus in the end, I will, if I have time, I will show you our small console helper in our application. Yeah, let's first go into a use case. As I said, I work at Ion. I think many of you don't know, Ion is in Europe the biggest electric utility company. We have around 40 million customers and roughly 70,000 employees, where we operate mostly in Central Europe, but also in some Eastern Europe countries like Romania, and also in Scandinavia like Sweden. The product I'm working on currently is called Ion Optimum, which is an energy efficiency platform for large B2B customers, where they can use our product to monitor their buildings and to see where they can maybe save energy, where they can reduce their CO2 consumption, or generally optimize their buildings. I now want to go into the application quickly and show you how it looks like in real life. Yeah, you cannot see it because my monitor is not. How can I quickly change it to mirrored? Go to settings.
What do you want to do?
Quickly mirrored.
You can just turn it to the projector ecran. Okay, like what's the website? This?
Yeah.
This?
Mm-hmm. Yeah, I try to do it like this. Maybe it's easier. Cursor, yeah.
Open it.
So, can we mirror the screen? Let me mirror it. It's easier.
Mirror, okay.
Mm-hmm. And we maybe stay in it. So, technical problems in the beginning are always good. But we can stay like that, so I don't need the presenter notes. Mm-hmm. So, we have that figured out. I go to our application right now. As you probably guessed, it's written in Angular and the web application. And when we go in here, zoom out a little bit, we can see the energy consumption of a customer. Here's like, here you see here's gas and water consumption in this case. I can then dig into my data more and can see more statistics about the data and can actually monitor days or weeks of the consumption and how they went over the time and can compare them if I find anomalies and can optimize them. Also, we built our whole application in a widget architecture. So you see here different graphs. If I scroll down, you see different kinds of visualizations for the similar data, but they can give more insights. If I then, for example, select a different week, all the other widgets are listening and now displaying the data you want to look at. If I show some more, you have like all kind of different energy visualizations, which are now data in my test data set, like we always know, right? But the most important thing is that I can create also my own dashboards and then customize them as I want to have them. So because customers of us said that, okay, it's nice what you built, but we actually need more. We need to create our own dashboards. So we built that as you can select a certain widget, add it to the stream, add maybe a data source to it from a site. We have water data, where I add the water data to the graph, and now I can see if I exit my edit mode, I've created my own dashboard. The cool part about this, if I reload the application, this was already persisted in the database, and if a customer logs in again, they can still see their dashboard. Yeah, that's roughly our application, what I wanted to show, to give you a little bit more context. I want to also quickly talk about our stack, because that's always important or always interesting to see. In the front end, we have Angular. In the back end, we use Scala and Java, and a mixture of a pretty big monolithic architecture and some Java microservices. And as a database, we run Postgres in the Google Cloud. This all together, of course, wrapped in Docker, run by Kubernetes, and we host everything on the Google Cloud. So this is our whole architecture, our whole stack, which enables us to quickly scale or to develop like a big enterprise application. Next, I want to talk about why should you think about sustainability and maintainability of an application in this scale. Because maybe I haven't said it, we work on this application now for 2.5 years with a team of maybe 20 people. So as you know, you need to write good code and like somehow maintainable code to really maintain some aspects. And if we talk about maintainability, we think about all the procedures which have to go on to help keep this application maintainable. But we also think about velocity. How fast can you develop a feature if the business comes and says like, hey, we need a new dashboard, a new functionality, we need to upload files, we need to download files. How fast can you develop it? It all depends on your code base, how well you structured it, because you need to extend it then. But also, we think a lot about code quality. What can we improve to make our code better, more understandable, maybe more explicit, to make it more easier for other developers to work on it. That comes also to onboarding, because many of you know, you work on big projects, you have maybe a lot of freelancers, and they come and go, and you need to onboard them and offboard them, and that can be a huge hassle if your code quality is not good enough to be self-explanatory, for example. In the beginning of this talk, preparing this talk, I talked to my coworker, and we tried to find a common theme of everything I want to show. And he said that, or we came to the conclusion that this sentence describes it pretty good. We try to let the compiler do the work and not us as developers. What does that mean is, as a front-end developer, you know this screen a lot because you develop something, everything is red, you don't know why, something is undefined, unknown, whatever. That happens a lot, and it's annoying. So what we try to do is we try to move the error from the console, from the unknown to the IDE with the help of TypeScript. So that we find our errors earlier and that the TypeScript compiler can help us as much as possible during our work. We asked ourselves, how do we get more predictability? How can we actually predict what our code will be doing? Because as you know, sometimes you write code and you deploy it on your production environment and all of a sudden it completely is broken or like you created a lot of new bugs. How can we write more explicit code? For the reasons I just mentioned, how can we write more explicit code so that other people understand it easily, maybe without documentation, because we all hate to write documentation, right? But also, how do we can have more unexpected side effects? Because a lot of times in JavaScript, you write a service, you write a component, you have like a complex structure, and during runtime, your object changes a lot, and you don't know what the actual state is, and you have to do a lot of debugging, a lot of logging to really find the reason. But also, because of velocity, how do we increase our development speed? How do we actually develop on our application, which is 2.5 years old, still in the same speed as if we are developing a prototype? This all led us to immutability, which is the first topic I want to talk about, and how we use it in our project. Quickly, for those who don't know what immutability is in this context, it is just the behavior of an object that you cannot alter it afterwards. So you have a variable and you set it to some value and you make sure that it will never be changed after you instantiated it. You will now think probably that, yeah, we have that, we can use a const or we can use TypeScript to make it read-only, but that is only weak immutability. Read-only only is for the layer or the layer you're on. So you make one attribute immutable, but maybe it's a very complex object with a lot of nesting, so that is not immutable anymore. And TypeScript or JavaScript in general with const or read-only doesn't provide the real immutability we needed, we wanted to have, because we know it from other programming languages maybe, and we thought that this will help us a lot. That was all the theory, and now we will come to code. So we will see some interesting stuff now. What we did is we assessed a lot of libraries. You know maybe Immutable.js. We assessed them and tried to ask us if this solution already exists, so that we don't want to build it, don't need to build it. But Immutability.js, for example, Immutable.js is called, is immutability during runtime. And what we wanted to do, as I've shown you, we want to move the error to our IDE, so we need it during compile time, or in our IDE during we work. And for that, we created a small type, which we called immutable, with a generic where we type in where we give in a certain type. This is a conditional type, and it is based on the type you give in. And so if it's a primitive, we just return the primitive, because in JavaScript, all primitive types we defined as this. So undefined, null, Boolean, string, number, function, they're already immutable. So if you pass them into a function, it's only a copy of it. So we can return the type immediately. If it's an array, we need to infer the type and create a deep immutable array, because we want to have this depth of immutability. This deep immutable array we defined as an interface which extends the general read-only array with our immutable type and the generic. So then we have an immutable array. If it's a map, we need to infer the key and the value type, put it into a deep immutable map, which looks the same. We extend from the read-only map and type the key and the value both immutable. But the most interesting part is, what if it's an object, right? Because sometimes you have very complex, very big objects, and you want to absolutely make sure that this object will stay as it is. So we created a type, which is called deep immutable object, with the generic again. But here we use the key map. We say the key in key of the type we pass in. And then you see here the small trick we did is we recursively called our immutable type and achieved this full immutability. So a coworker of mine said, it's nice that you show them some code, but you actually need to prove that this or how this works. So I want to switch over to some code and show it to you, as in live coding is always so easy. So what I did here is the code I've just presented to you is we put that into our own immutability file, and I just, by the way, can you read that in the back rows? Okay. So what I just did is I imported my own code and can now use the immutable. What I did here is I created a small interface for user and made an instance of this user with the user ID and email. That's boring because it's shallow. But what happens if it's a nested object, right? So you pass in an options object, and in there's a language. And if I now assess this user object and say, I want to alter the options to the language, and I want to set it to, let's say, Russian. Now, everything is fine, right? Because it's just an object, I manipulate it, and that's what we expected. But what we do a lot of times is we type now our user type as immutable, and we say, now it's immutable, right? We actually want to make sure that this will never be altered again. And what TypeScript now does is it helps us during compile time, during development time, it helps us to say, hey, it cannot assign language because it's read-only property, because it was deeply immutable. Even cooler is if you have a function and it has parameters, you can also use it and can say this now is immutable. And because TypeScript is pretty cool nowadays, it now can understand that the parameter which is given in will be changed and will stay the same. That's immutable now. Yeah, that was basically what we learned through our immutable structure, and how that helped us to achieve all the more explicit code and less side effects in our code. The next example is way smaller than the immutability code, but it helped us, I would say, the same amount. We started to type our IDs, and what that means is, or what problem we solved is the following. So imagine you have a user object, and you get the user by some ID, as you usually do. So the function may look this is just demo code, but you have to get user by ID, you pass in a user ID, and you get back a user, and you search your user in some list. But you run into the following problem. This user object is always undefined. So now you can debug it a lot and search for your IDs and compare UUIDs to another, and try to find the error in your application, but you cannot find it. And that's because you accidentally passed in an order ID, because in JavaScript or in TypeScript, we treat IDs usually as strings. So the TypeScript compiler cannot help you in any way. And what we did here is we just created a small interface, which we call, in this case, user ID, and it extends the string. We needed to do a small hack, because this alone is not enough, because here you have an interface, and in TypeScript, an empty interface is always equal to another empty interface, no matter what the name is. So what we did is we gave it a unique attribute, which we call here user ID, but also for other IDs, we can then call it order ID or account ID or whatever. But we type it never, because actually that's only a hack for us in the background in TypeScript. We don't want to instantiate from this object. And to use this interface now, we create small functions, which in this example is called as user ID. And we pass in a string, and we get back a user ID. This is actually, we don't want to use that interface or touch it in any way, but we want to tell the TypeScript compiler, hey, what I have here is now a user ID. And the problem we solved with that, again, I was asked to show that, I can show you in code. As you see in the first 6 lines, I created the two interfaces. Once a user ID and once an order ID. I created my two functions, as user ID, as order ID. And now I have the following problem. I have here instantiated a user ID, which is just a random string, and an order ID. And I have a function here, which is called getUserById, as we know it. And I passed in my order ID, but nothing happened, of course, because just strings, TypeScript compiler cannot not help you in any way. And what I can do now, it's a little bit harder with one hand, but what I can do now is I wrap my two IDs with my new function and actually declare them as an order ID or as a user ID. And what I can do now here is to use my interface to type it correctly. So I say, now I want to have a user ID. And I made really sure that now this throws an error, because the order ID is not equal to the user ID, right? So now we achieved this very strict code, which not allows this problem anymore. And you now think, yeah, but I can handle my IDs pretty well. Even when we implemented this, we found errors in our own code, which we never understood how it actually worked, because there were wrong IDs in wrong places. So this is pretty neat and helped us a lot. With this, you will never confuse your IDs again. And the third example, the last example, will be assert unreachable. It's even shorter than user IDs, but for me, I would say the best one. For those of you who heard the term already, they know what comes now, but for the other one, like me, I didn't know the concept, but we implemented it, and it's really, really helpful. Imagine the following problem. You have some enum with a status. I try to come up with somehow real examples, so it makes more sense. So you have an export status. It can be successful or failed. Then somewhere else in the application, you switch on your status. If it's successful, you set a loading icon to successful. If it's failed, you set it to failed. I mean, my creativity level was not the highest. But what happens now if you need to cover all the cases in your switch statement, but you add a third case, maybe pending, because you have a loading bar or something, and it can be pending, and you also want to display it. In those cases where you have like multiple values and you want to make sure that everything is handled, usually you throw in a default case, right? Where if you didn't handle everything and it's not really necessary, in all other cases, you can do something else. But sometimes you really want to make sure that you covered every case. And with the assert unreachable, you can achieve that. Because what we do now is, in our default case, we put this assert unreachable and pass in our status. How does this function look like? I said even less code than user IDs. So the assert unreachable is just a really, really small function where we pass in a parameter, which we type never, and we return never. Seems unuseful because you can never do anything with it. And inside, we even throw an arrow and say, like, assert unreachable triggered, whatever. You can almost forget this code again, but what is important is what happens now in our code. Because the TypeScript compiler now knows that, hey, I have 3 possible cases, but you only covered 2, and I can possibly run into this function, but we asserted it to be unreachable. So what the TypeScript compiler now knows is, hey, you said you don't want to reach this, but you can. And now we can actually make sure that we cover every case. And if you, as a developer, imagine you have a really big project, and you have like huge enums with a lot of things in it, like we do, and these enums are used in multiple locations in the code, and you extend the enum with another type or another possibility, and then you need to keep track of where do I need to extend my code. This is super easy now, because you asserted unreachable everywhere, and the TypeScript compiler will guide you now through your whole code where you need to cover it. And if I now go into the right locations and add this case, everything is fine again. Because now you see the last case, the default case, can never be reached. So that was super helpful for us. With this methodologies or this small hacks, we increased our extensibility a lot because adding a new enum or something, adding a new case to your enum is now super easy. But also made our code more robust because now it's so easy to handle every case. You throw it in and you actually make sure that you use it everywhere. And if you once used it, you want to use it everywhere. So it's pretty nice to have. And we made our handling more explicit because in some cases, as you know, you write some code and you don't handle a case, you deploy it to production, and all of a sudden a never tested case happens, and your whole application breaks. And with this, we kind of work around that. But we as developer, we get more confidence because if the console doesn't say anything, if the TypeScript compiler is quiet, then we kind of thought of everything. And I don't know how much time I have left. 3 minutes, that's enough. I want to show you something. Code is over. I will not show any more code, but I want to show you something really, really fun and helpful. We wrote ourselves a small console helper. What is that? Try to make a small GIF. We can now go into our console and call code or manipulate our code from our console. This is especially helpful because sometimes you have a pretty big stateful application or you use Redux or something, and we all know that you dig around in the Redux dev tools or you make a lot of console logs or breakpoints to find something. But sometimes you only want to alter some code or try something else or call a function. And with this small console helper, we made it possible to call code from within the console, the browser's console. And here, in this case, I just called a custom namespace. I called this function, which I previously defined, front-end version, and it now returns me the whole front-end version. But this is artificial. It's a test case, but I can show it to you in the real application because it is way more complex and what I actually mean by state. If I go here in my console, can make it bigger? Yes. In my console, we called our namespace EMS, and I call now functions on it. And I can give what I didn't mention in the first place. Our whole application is separated in dashboards and modules, and we have this whole architecture I cannot cover in this talk, but I can get a list of all my active dashboards. And if I call it, it gives me all the active dashboards. This is a state in our application, and I don't want to dig around too deep into Redux or something. And if I want to do more now, I can call it again and actually get the whole state of my current dashboard. When I pass in the ID I just got, and I call it, and what I get returned is a whole object of my whole dashboard application, where I can see, hey, this is a read-only dashboard, or is it visible? Yes. Is it volatile? No. And I can quickly go into my code and see some stuff or call some stuff, and this is pretty helpful. You probably now wonder where you can get this code, and I will show it later. But yeah, to conclude the talk, I wanted to show how we develop a sustainable application and what small tricks we do to increase our maintainability, how we use immutability in our code to increase our explicitness and our confidence in our code, how typed IDs helped us a lot, what assert unreachable is and what you can use it for, and the small console helper. But all the code you've seen, I've put on GitHub, and you can actually go to this QR code and play around with it, check it out. Maybe also give me feedback if you find a bug or you have a cool addition to it. Yeah, feel free to make a pull request if you have an advancement to it. That was it. Don't forget to let the compiler do the work, and thank you very much.
Thank you very much, Leo, for this nice and very intense talk. Now let's switch to the Q&A session. Guys, I'd like to ask you to ask the question in English. If you don't mind, if you Если вы не можете по-английски спросить вопрос, задайте по-русски, мы как-то попробуем перевести, хорошо? 5 минуток где-то на вопросы.
Thank you for your talk. I really enjoyed the immutable type helper. And the question about it is, how do you deal with updating objects? Because
With what?
updating properties, changing properties, because if you have this immutable helper, it gets more complicated. You have to do typecast back to the mutable version, or what do you do? Like in functional programming, there's the whole thing with lenses and stuff, but that's kind of complicated.
It's a pretty good question, and of course you don't have to use it everywhere, obviously, but I left out a pretty important part because while preparing the talk I was deciding that it was too much, but now you know how to get it immutable, but what if you want to get it immutable again? And usually what you do in other frameworks and other languages is you clone it, right? And we have our own cloning helpers, and if you go to the repository, you find them there. So the repository is complete, but I left them out here because it was too much code and I needed to reduce it a little bit, so the clone functionality you will find in there. As the same, maybe to add, I forgot to say it, but the same for the IDs. Now, if you type your IDs with this helper, it's not a string anymore, but sometimes you want to concat or to manipulate your string, and of course you just use the toString method, which is native. So you're right, you always need the way in and the way out again.
Okay. Еще вопросики, ребят? Any more questions to discuss?
По-английски?
Everything was clear. По-русски? По-русски?
You can also ask later if you want.
Right. So just catch Leonard on the corridor or even in bar after the talk, after the meetup.
That's probably the best with the beer.
Yeah. Right. Во время чая и пива могут возникнуть новые вопросы. Так что ловите момент. Leonard, are you here for some more days?
Yeah, I'm here until Saturday.
Okay. So, другая возможность
To
встретиться
explore
не
this
только
beautiful
сегодня.
city a little bit more.
All right. Very good. So thank you very much, Leonard.
Thank you.